Trigonometry, Chapter 7, Applications of Trigonometry, Vectors, Section 1, Oblique Triangles and the Law of Sines. Video 8, The Law of Sines, Ambiguous Case, Example 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we classified the number of solutions in the ambiguous case of the law of sines, where we were given two sides and an angle not included between them. Given side A, side B, and angle A, we drew four conclusions. If A is less than B sine of A, there are no triangles. If A equals B sine of A, there is one right triangle. If B sine of A is less than A, which is less than B, there are two triangles. And if B is less than or equal to A, there is one triangle. This is a hot mess. I don't have it memorized. I could sit down and memorize it, but I'd rather understand and be able to analyze a problem in a given situation. Nice in theory, not so nice in application. So we're going to jump right into an example. Suppose triangle ABC. We have side A is 10, side B is 25, and angle A is 76 degrees. Solve triangle ABC. In other words, find the remaining sides and angles. Now, we could compare side A to B sine of angle A and determine how many solutions to expect according to this. So let's try that and see what happens. Well, if you use a calculator to evaluate B sine of A, that's 25 sine of 76 degrees, which is approximately 32.1. And notice that A is less than this. A was 10, B sine of A is 32.1. Since A is less than B sine of A, since A is less than B sine of A, there are no triangles. Problem's over. So what's the big deal? Well, here's the problem with what we just did. First off, it's easy to mix up the conclusions based on comparing A to B sine of A. In other words, it's easy to get this list of things mixed up. And the choices for these variables is arbitrary. What if the problem had stated that side P equals 25, side Q is equal to 10, and angle Q is 76 degrees? Would you be able to easily adapt to this with A's and B's, whereas this is P's and Q's? Now, maybe you can, but it presents an unnecessary obstacle towards our goal. So as correct and as complete as this is, I think it's more trouble than it's worth. So why don't we do the previous video for theoretical completion purposes? Excuse me. So one easy way to avoid all of this is to completely forget what we saw in the previous video. It hurts me to say that because I'm a theoretical mathematician, but I understand that when it's time to go to battle with the trig problem, sometimes you just jump in and see what happens. I know this sounds counterproductive. Why bother making a list if we're going to discard it? Well, we're not actually discarding it. I'm just showing you a way around it, and you decide which approach is best for you. So how do we go around this list that we made in the previous video? And the answer is you just jump right in the problem and see what happens. To completely forget what we did in the previous video, we simply delve directly into the law of sines. If there are indeed no solutions, the math should lead us to that conclusion. Now we're given side A is 10, side B is 25, and angle A is 76 degrees, and asked to solve triangle ABC. In this case, we set up the law of sines for the given information. So sine of A over A, so sine of 76 over 10, equals sine of B over B, sine of B over 25. Let's solve this. Multiply both sides by 25. You could cross multiply, but we're trying to solve for B. So I think multiplying by 25 is the better move. And then we use sine inverse or inverse sine. We get B equals sine inverse of 25 sine of 76 degrees over 10. And use a calculator, and we get some sort of a domain error. I meant to pause there, but if you put this expression into a calculator correctly, it should say something like domain error or undefined or a non-real answer or something like that. And if you get some sort of a domain error, the reason why is because the thing we did inverse sine of, the thing inside the inverse sine, was greater than 1, which is outside of the domain of inverse sine. So inverse sine of that expression does not exist, which means no such triangle exists. From this Desmos video, we can see that a length of side 10 is too short to reach the base. In other words, going back to Desmos for a second, I've already got it set up for side A to be 10, side B to be 25, and angle A to be 76. It's not labeled over here, but angle A is in the bottom left. This is side B in black and side A is in red. And if you notice, side A is too short to reach the other side. So, do you want to memorize that list of criteria that says when to say what about the number of solutions? You're welcome to, but my advice is don't. Just jump into the law of sines, do the math, and if there's no solutions, you'll know when you do sine inverse and it gives you a domain error. Now, pause the video and try this one. I bet you know how it's going to end. Here's your warning if you haven't paused the video yet. Solutions in 3, 2, and 1. There's actually two answers. Number one, we can figure out B sine of A and get about 81.9, which is greater than A. So our list of conclusions says no such triangle exists. Or, more preferably, we can jump directly into the law of sines. Sine of 55 over 19 equals sine of B over 100. Solve to get B is sine inverse of 100 sine of 55 degrees over 19. And your calculator will say undefined, no such triangle exists.